I'm Greg Monaghan, Applications Manager at Specialty Polymers. I've been with Specialty for about 5 years now, working on developing uses for new polymers that the chemists at Specialty have come up with. For those of you who don't know, Specialty Polymers has been in business for more than 50 years now. It's a family-owned business, and we focus on developing and supplying water-based polymers in the coatings and adhesive market. Our niche in the coatings industry is the way that we provide support to all our customers, both large and small, and that we can bring products to market on any scale to fit our customers' needs. I think that the talk today is a good illustration of how we develop one of the products and the value that we can bring to our customers. And before I get started, I'd also like to thank the Cleveland Coating Society for putting on this virtual Sink or Swim conference so that we can discuss these new technologies, even in a time when most of us are not traveling. Today I want to talk about some developments in polymers that are designed for coatings for tennis and pickleball courts. As you might imagine, the coatings on these courts have to stand up well to things like ponding water, abrasion from the stops and starts during a tennis game, have really good UV resistance in the full sun, and still also have great adhesion to the substrates. With all these requirements, it's possible to have some significant failures, and with tennis courts, a failure is often quite expensive. Although you often find vanilla acrylics that are being used in these tennis court applications, it is possible to design the polymers specifically to address some of the problems that can occur with these coatings. Let me just tell you a little bit about pickleball, for those of you who don't know what it is.
Pickleball is a sport that's growing in popularity with seniors as well as other age groups. It's kind of a combination of tennis, ping pong, and badminton. It's easy to learn, and it can be a very social sport with lots of opportunity for smack talk during the game.
It also is much less physically demanding
than
tennis.
The courts are smaller than traditional tennis courts, and frequently lines for pickleball are painted inside the lines of tennis courts, as you see here.
Because of the smaller playing area,
there's less side-to-side running, and you're restricted from playing in the front of the court near the net. The ball speed is also slower. The serves are underhand, and you use a ball like a wiffle ball with wooden or composite paddles. I'm sure that some players will take exception to my calling it slower, however. Believe me, there's some very competitive pickleball leagues.
So you can see that if you're making a tennis court coating, you're also making a pickleball court coating. It might be something to keep in mind as more and more of these courts are being built, and they're not only in senior communities these days.
So what is a tennis
So
court?
what kind of coatings are used
These are made
in a
of
tennis
multiple
court?
layers of coatings
These are made
applied
of
to
multiple
asphalt
layers
or
of coatings
concrete
applied
substrates.
to asphalt or
Asphalt
concrete
courts make up the
substrates.
majority of
The
all
asphalt
hard
courts
courts.
make up the
It's
majority of
somewhat
all hard
flexible
courts.
and able to give
Concrete,
slightly with
while it's
ground
harder
movement
and
due to
generally more
settling and
expensive than
freeze-thaw
asphalt,
cycles.
has
But
fewer
as it
cracking
ages and
problems
weathers,
than
it
asphalt does.
oxidizes, shrinks, and hardens,
The first
making
coating
it less
applied is
flexible
typically a
and more prone to
resurfacer
cracking.
coating containing sand.
Concrete, while
This
harder
coating
and generally
fills
more
some
expensive
voids in
than
the
asphalt,
substrate and
has
also
fewer
provides
cracking.
Tennis court coatings are applied in relatively thick films at around 150 square feet per gallon, or about 10 mils wet film thickness. The cushion coats can be much thicker at about 50 mils or so. These coatings are usually applied using a soft rubber squeegee. The paint is poured in a line across the court, and the squeegee is used to spread it using back and forth passes across the court. Often 2 coats can be applied in a single day with about 4 hours of dry between them. I just wanted to show the application here. It sounds easy, but it's actually a very skilled technique to avoid having raised lines between the passes of the squeegee or at the end of the run where the squeegee is turned. Any raised lines can affect the play of the court, of course. The size and the shape of the sand can also affect the tool marking. The smaller, more rounded grains leave fewer lines in the top coat when applied in this manner. Some folks claim that they roll under the squeegee rather than being dragged along. There are several types of failure which are possible on tennis courts. In freshly applied coatings, it's possible to get blistering if the film is exposed to water, or if there's moisture under the film from the lack of a vapor barrier. The puddling of water on the surface is considered a major problem. If the puddles are about 2 millimeters deep, or the technical term used for these puddles is kind of funny. The technical term used for these puddles is kind of funny. Means that the substrate needs to be patched or regraded to improve the drainage. So it's a big regraded to improve the drainage. Water on the surface can also make dirt pickup. Water on the surface can also make dirt pickup, algae, and you can also get failures if the coating is applied when the temperature is too cold. You can also get failures if the coating is applied when the temperature is too cold. This can lead to what's called crumbling of the surface. Typically, the coatings are recommended to be applied when temperatures are 50 degrees and rising, meaning in the morning when temperatures are expected to rise, but not in the evening when temperatures are expected to rise. But in older courts, you sometimes see cracking. Usually this is from cracks in the asphalt substrate, which gets more brittle as it ages. The asphalt substrate, the cracking can have many causes depending on the different stresses on the court. The cracking can have many causes, but it can sometimes be accelerated by stresses from temperature differences between the white lines and the court. Between the white lines, I mentioned that you can also get loss of sand from abrasion on the court. Here are a few of the properties you need in a tennis court coating. Early water resistance is one which often comes up. If you have poor early water resistance, you can get blistering, which usually leads to complaints. The technical data sheets for these coatings always say that they should cure at least 24 hours before being exposed to rain, but early exposure to water does happen in the field. Often the paint companies would like to have their paint stand up to exposure to water after only 4 to 6 hours of dry to give themselves some insurance. Because you have thick coats and short dry times, this can be quite difficult to pass. Having a coating with good wet and dry adhesion is also important, not just for the long-term durability of the coatings, but also to improve the blister resistance, since the adhesive forces can counteract the forces pushing the coating from the surface to form the blister. There are silanes and adhesion modifiers which can give improved adhesion to the aggregate in the substrate. These modifiers can also improve adhesion to sand, helping reduce. In addition to the adhesion modifiers which can improve adhesion and sand retention, it's also possible to build ambient temperature crosslinking into the polymer. I'm showing one type of crosslinking that could be used, the diacetone acrylamide adipic dihydrazide crosslinking. These are 1K systems. The components are very stable in the wet paint and only react once the water leaves the film. You have the diacetone acrylamide attached to the polymer and the adipic dihydrazide in the water phase. The two molecules react by a condensation reaction of the amine on the pendant carbonyl and splitting off water. Because the water must come off for the reaction to go forward, the reaction does not occur in the wet state in the can, but only after the film has dried. This particular reaction is quite rapid. Polymer companies have used this crosslinking for improving chemical resistance and some hardness properties, but we have found that it significantly improves some properties of tennis court paints. This shows one benefit of the crosslinking. We see a significant improvement in the early blister resistance. These two polymers were both all acrylic with a TG of around 7 degrees C. They were the same except for the ambient temperature crosslinking in the paint on the right. We cast a 20 ml wet film, dried it for only 4 hours at room temperature and 50% relative humidity, then placed the panels in water and soaked them overnight. It's quite a severe test. The crosslinking also had a very large effect on the abrasive scrub resistance. The paint with the ambient temperature crosslinking had much better scrub than the paint made with the acrylic analog without the crosslinking. This may indicate that the abrasion under foot traffic would be much better for the cross-linked paint. We think that the improved abrasive scrub resistance is a result of the interpart. You can see the tougher film in the increased tensile strength of the cross-linked paint. It increased from 249 to 582 psi for the cross-linked paint. As you would expect, we got lower elongation when the tensile strength increased, but the elongation of the cross-linked paint was still very respectable at 376%. Too much elongation can hurt you, of course. It's a little difficult to see, but this shows the difference in dirt pickup resistance with the added crosslinker. These were 3 mil drawdowns on aluminum that were dried for 1 week. To test the dirt pickup resistance, we then applied iron oxide slurry to the surface and dried it, then washed it off the surface with light rubbing using a wet paper towel. The crosslinking gives you less color change, indicating a slight reduction in the softness of the polymer. We also wanted to evaluate the cross-linking acrylic against a couple of competitive polymers commonly used in tennis court paints. Polymer 1 is the experimental self-crosslinking acrylic. It is 50% solids, 7 degrees C Tg, and 0 degrees C MFFT. Polymer 2 is a competitive all-acrylic polymer at 55% solids, 10 degrees C Tg, and 4 degrees C MFFT. Polymer 3 is also a competitive all-acrylic used in tennis court applications at 65% solids, 12 degrees C Tg, and 9 degrees C MFFT. This is the formulation for the top coat or the color coat without the sand. It's pretty standard except for a relatively high level of adipolgite clay and using only HEC thickener. Both the HEC and the adipolgite help reduce settling when sand is added. It has a volume solids of 36% and a PVC of 20.5%, so there's plenty. These are the results of the testing of the competitive polymers. You can see that polymer number 1 with the crosslinking was much better for abrasive scrub resistance, for low temperature flexibility, for tensile strength, and for dirt pickup resistance. This may indicate a better balance of abrasion resistance and hardness than the competitive polymers. These are the panels from the abrasive scrub resistance test. The scrub was run side by side with the crosslink control on the left. You can see that the control had much higher abrasive scrub resistance than the competitive polymers. This may indicate better abrasion resistance on the tennis court. We ran the Tabor abrasion resistance with and without sand. It was interesting that there wasn't much difference without the sand, but in the testing with the sand, the darker orange bars, the crosslinking acrylic had much lower weight loss than the competitive acrylics. This may indicate that the sand retention of the crosslinked acrylic is better than the. This shows the early blister resistance of the three polymers after a 6-hour dry. The crosslinked acrylic was much better for early blister resistance. Even though we would not recommend applying these paints if rain is expected in a few hours, this indicates that the crosslinking would give. The better blister resistance might be due to a less water-sensitive film. In the water swell test, even after 1 week of soaking, the cross-linked acrylic had a lower weight gain than the two competitive polymers. This is the low temperature flexibility test using a 15 ml drawdown of the coatings. The panels were aged for 1 week, then refrigerated at 15 degrees Fahrenheit and bent over using a 1/4 inch mandrel. Polymer 1 had good crack resistance in this test and would be expected to flex even with the stresses. These are the panels from the dirt pickup resistance test. The cross-linked acrylic had better dirt pickup resistance than the competitive polymers. So even though it had better flexibility in the low temperature flex test, it didn't pick up as much dirt. Again, this may be due to the cross-linking in the polymer. So you can see that if you compare performance with and without crosslinking using the same acrylic backbone and surfactant package, you get better early blister resistance with the crosslinking. This gives the paint maker some insurance against failures due to sudden rainstorms. The paint with the crosslinking also has much higher scrub resistance, which could indicate better abrasion resistance, and it has better dirt pickup resistance. Compared to the competitive acrylics, the crosslinking acrylic had much higher abrasive scrub resistance and better Tabor abrasion resistance. The higher Tabor abrasion resistance for the crosslink polymer formula with sand may also indicate better sand retention, which would give less frequent recoats. Finally, it had very good low temperature flex. Thanks for your attention. If you'd like to send me any questions, I can be reached at this email address. I would be glad to talk with you about this project. And one final thanks to the folks at the Cleveland Coating Society for putting the symposium on. Enjoy the rest of the symposium and have a great day.